Problem statement. I have two sets of population with 15 data points in each. This is my population 1, this has 15 data points, and this is my population 2 with 15 data set. Population 1 has a standard deviation of 1.33. That's given to you. And the population 2 has a standard deviation of 6. And I plotted them for convenience right here. This is my population 1 graph and this is my population 2 graph. Now both population have exactly same mean. So mean in this case for both of them are exactly same. And we have to determine that mean value. So I do not know what that mean value is. That's what you have to find. If I'm allowed to take only 10 sample points to determine the mean value, which population should I use to get better estimate of my mean value? This session is about answering these types of questions. This session is about sample size. Now, let's look at some of the factors that affect the accuracy of estimate. Sample size is one of them. If you have a small sample, this will give you more uncertainty. You would be less confident. Your result would be less accurate. If you have a large samples, then this will give you less uncertainty. You will be more confident, your results will be more accurate. Let's understand this through an example. Let's say I have this population with 6 data points over there. My data points are 2, 2, 5, 4, 3, 2. And I calculate the mean of my population and the answer comes out to be 3. This is my mu. I take a sample of just 2 points, 3 comma 2. Okay, these are my 2 points, and I calculate the mean of my sample points, and answer comes out to be 2.50. I do the same thing for this right here. This population is exactly same as this population. They're essentially same. In this case, my population mean is also 3, and this time I take a sample of size 4, and I calculate my mean for my sample. It comes out to be 2.75. You can see 2.75 is more closer to 3 than your 2.50 is. So if you have a large sample, like in this case right here, your sample mean is going to be more closer to your population mean. If you have a small sample, like this one right here, your sample mean is going to be less closer to your population mean. Let's look at another factor that affects the accuracy of your estimate. It is the variability of your population. Another word for that is the standard deviation. If you have a high variability, in other words, high standard deviation in the population, this will give more uncertainty. You will be less confident, your result would be less accurate. If you have a low variability, in other words, low standard deviation in the population, this will give you less uncertainty. In other words, you'll be more confident and your result will be more accurate. Let's understand this through an example. So I have this population right here. And look at my data right there. 1, 50, 40, 300, 207. And the mean of all these numbers is 96.6. I calculate the mean. Basically, you add all the numbers together, divide by 6, and the answer is 96.6. Now look at the numbers. Just by looking at the numbers, you can see that they are varying all over the place. The minimum number is 1, and the maximum is going up to 300. You see there's a big variation over here. Now I take a sample of 3 points. Let's say I take these 3 points right here, and I calculate the mean of these sample. And the answer comes out to be 30.3. Now let's look at this population right here. In this case, my points are 90, 98, 100, 93, 102, and 96. And look at these numbers. They don't have a high variability. They're very close to each other. They're anywhere between 90 to 102. Most of the, all the numbers are between 90 to 102. They don't have a high variability. In other words, they don't have a high standard deviation. In this case, I calculate my population mean, I added all the numbers together, and my answer comes out to be 96.6. Same as this population, 96.6. So I took a sample of 3 points, which is this right here, and I calculated the sample mean, and my answer came out to be right here, 96. And look at this 96. This 96 is a lot closer to this 96.6, your true population mean, than this 30.3. So a low variability in your data, a low variability in your population, what it means is that your sample mean is going to be a lot closer to your population mean. If you have a high variability, high standard deviation in your data, like this one, your sample mean is going to be less closer to your population mean. So, how large a sample is necessary to make an accurate estimate? We can derive that using a simple equation. We know that the formula for margin of error right here is given by this expression right here. In this case, my E is the margin of error, my sigma right here is the population standard deviation, and Z right there is the critical Z value. So from this expression follows, and from this expression, you get this right here. This one tells you your sample size right here. In this case, your E is the desired margin of error, the maximum acceptable difference between the sample mean and the true population mean. Your Z is the Z score. It corresponds to different confidence level. It's going to be 1.645 if you're using 90% confidence level. It's going to be 1.96 if you're using 95%, or 2.58 if you're using 99%. This is the most commonly used values. Now, the answer to the above question, it depends on three factors, and those three factors are these ones right here. Margin of error, that's the first one, which is this right here. You ask yourself, how much error are you willing to accept? Well, if you want less E, choose a bigger sample size. You can see the relation between your E and sample size. As your E increases, as your E goes up, your N is going to go down. Okay, this is their inverse relationship. All right, now let's look at the population standard deviation. Well, you ask yourself, how much variation in the data exists? If your sigma is high, okay, so again, look at this expression right here. If your sigma is high, then your N is going to be high. Then more samples are needed. How about your degree of confidence? Degree of confidence. Degree of confidence, that's controlled by your critical Z value, which is right here. You ask yourself what percentage of confidence level you want. If you want a high confidence, in other words, you want a high Z alpha node, high Z, that means your Z goes higher. Well, if your Z goes higher, that means your N is also going to get higher. That means you need more samples. So, an aerospace engineer, he's trying to estimate the average fuel consumption rate of an aircraft engine. So, for flight planning and performance certification, he needs a 99% confidence that the estimate is within 2 gallons per hour of the true mean consumption rate. This right here is your E, is telling you the margin of error is this thing. And 95%, 99% confidence level, that tells me your Z right there. Flight test data shows that a standard deviation of 4.3 gallon per hour. So we know our sigma right here. How many minimum samples he needs? So I need my N right here. So I know my Z is 2.58 because it's 99% confidence level. I know my sigma, which is 4.3, which is given to you right here. And I know my margin of error, which is 2, which is right here. So using this formula, this right here, I substitute my value of Z, sigma, and E in it, and the answer is approximately 32. If it's not exactly 32, it may be like 31.5 or 31.6 rounded off because that's the number of samples. So I rounded off and the answer came out to be 32. So to be 99% confident that the estimate is within 2 units of the true mean, the engineer needs a sample of at least 32 measurement. He can have more than that, but at least he needs 32 measurement. An aerospace engineer is estimating the average fuel consumption rate of an aircraft engine during cruise conditions. For flight planning and performance certification, the engineer he needs 99% confidence that the estimate is within 2 gallons per hour of the true mean consumption rate. This right here, that's my error of margin 2. Flight test data shows that the standard deviation of 4.3 gallons per hour. This right here is my population standard deviation. How many minimum samples he needs? In other words, you have to determine N. In this case, I know my Z, right? Because you know it's 99% confidence. So for 99% confidence, if you go back, the 99% confidence was Z value was 2.58. Okay. So I know my Z is 2.58. I know my sigma is 4.3. It's given to you, right here, standard deviation. And I know my E. The error of margin is 2, which is right here. Oops, right here. So using this formula, calculate your n, and the answer will come out to be something like maybe 31.4, 31.5. Just round it off to integer values because that's the number of samples. In this case, I rounded off, it came out to be 32. So to be 99% confident, the estimate is within 2 units of the true mean. The engineer, he needs a sample of at least 32 measurement. He can have 33, 34, 35 measurements too, but at least he needs 32. I have two sets of population with 15 data points in each one of them. So this is my population 1, and the standard deviation for the population 1 is 1.33. This is my population 2 right here, and the standard deviation of population 2 is 6 right here. And I plotted these population right here. This is my population 1, and this is the mean value of population 1, and this is my population 2, and this is the mean value of population 2. Now both population, they have exactly same mean value, mu. And we have to determine that mean value. You can see by looking at this graph that this one actually has more standard deviation. Population 2 has a more standard deviation than population 1. Now, if I'm allowed to take only 10 sample points to determine the mean value, which population should I use to get a better estimate of my mean? Well, from my relationship, the relation between your error of margin and your standard deviation is, which is right here, this relationship, you can see that this expression, your E, is directly related to your standard deviation. So if your standard deviation goes higher, your error of margin will also go higher. Your accuracy will go down. If your standard deviation is low, then your error would be low. Error of margin would be low. So we see that our E, the margin of error, to be minimum when we select our population with the low standard deviation. You want your sigma to be as low as possible, for this to be as small as possible. In this case, we are going to select population 1 because it has low standard deviation. And this will give you the low margin of error.